Hello everybody, this is the video tutorial for the S60-127 CAD model for the flywheel. So this is a part that has one major revolve feature and then can be made with the rest with uh, extruded cuts and the whole wizard. Okay, so what we're going to do is we're going to look at our drawing first. And the drawing gives us a pretty good section view on the right hand side. So if you can visualize the area that we would model for our revolve would be pretty much one half of our section view. And we can either elect to put the chamfers on in that revolve view or put them on as it's a model. Okay. Then planning ahead, we would then cut through one of these windows, and you'll be learning how to use the revolve pattern feature to duplicate those so that you draw one and pattern the other two. And then we have a hole that's a press fit hole for a 2mm pin, and and halfway through in the other half is a threaded 632 thread, and that accepts the thread on one side of the part you already developed called the axle. All right, and so this is a pretty straightforward part, more features than you've made before, but we just take it in methodical order. We do have a very small feature, this small disc look feature that's only 8mm, I'm sorry, 8 thousandths thick. Yeah, it behaves somewhat like a washer, so don't forget to include that detail. And that detail is not included in the overall height of the part that's shown in this top view. These two dimensions are to the edge here, and that's why there's a detail view to blow that up and show you exactly where that is. All right, let's go to SolidWorks and we'll get started. We're going to draw a center line section, and then we're going to draw each side of this rectangular feature. Looks kind of like a hammer, and rotate it around the hub. Okay, so we're going to create a new file. It's going to be a part file, and we're saving that as the 127 in the proper format. We're going to make our planes visible. And in the front plane, we're looking at a circle. So if we're going to revolve that, we need to do our sketch in the right side plane. Okay, so we're going to go to sketch, sketch mode, pick the right side plane. I also like to use the other planes for symmetry. So in the case of this part, I'm going to put the center of the spoke actually on the center of the vertical axis here. Alright, so starting out, we're going to start with a line. We're going to start at the origin. We're going to go right, and then we're going to go up, and this would be half of the hub. We're going to come in, and this would be half of the rib structure. Then we're going to jog out, and this would be half of the rim, going over to the other side with the other half of the rim. If we're careful, we might be able to get a collinear relationship here. That didn't work out. Anyway, we jog down, and we're going to draw the other side of the hub, and I believe that side of the hub had the extra jog out for the washer-like feature. And then we can come back to origin and merge it. And we should have an enclosed space. Let's go double check I did that right. Yes. Okay. Now, we're going to put in some relations first. So let's exit the line tool. And we want to make the lines that should be collinear. So those two are collinear. The line here and here is collinear. The face of this rim and this side of the hub is collinear. Okay, but the opposite side is not. All right. Now we can throw our center line in. So pick the line tool, but drag down a center line. Pick out in space. Pick out on the right in space. And you want to make sure that's in alignment with the plane that intersects the plane you're drawing on. And, oh, there's one more relation I forgot to put in. We're going to put a center line. And it's going to go from the midpoint to midpoint on the rib feature here. And we're going to select on the center of that line feature, and then with the control key down, click the plane in the center. And we want to make that coincident. And that way this, at least everything but the hub and the washer feature will be symmetrical around the center line. Alright, so let's start doing our diameters, and we're going to start with the smallest diameter first, which is this, I believe, which is this washer shape. So let's try that and see if that works. So we're going to go from here to origin. We're going to go from the horizontal edge to the center line. And drag down, click. Our diameter according to the drawing for that feature is 240 thousandths, so 0.24. Okay, then we're going to go to the next largest diameter, back to center line. Drag down below the center line so we get the diameter. And we're going to go to the diameter of the hub itself is 470 thousandths. So it's 0.47. Okay, that shrinks down significantly. Then we're going to go to this next outside diameter. So it's the inside of the rim. And that diameter, according to the drawing, is 1 inch, 540 thousandths. And then our last diameter is going to be the outside of the part, the center line, at 1 inch, 940 thousandths, just under 2 inches. Alright, so we have all our diameters. The part looks a little squatter than our drawing because we haven't done any of the widths. Okay, so let's start with, let's start on the inside and work our way out. So if we look at our drawing, the width of the rib is 140 thousandths, and it's 126 thousandths from the forward face. So let's set that 126 thousandths first. So from the front face of the rim to the bottom of the pocket, is 126 thousandths. Okay. And then the width between the two in the rib was 140 thousandths. Okay, so we've gotten a little wonky here. We could have put in a relationship to make the rim equal. So we should probably do that. Let's exit the dimension mode, and we're going to highlight the edge on the right, hold the control key down, highlight the one on the left, and we're going to make those equal in length. So with that combination, we don't need to put in the width of the outside rim. It's already been calculated by the dimensions we put in. Alright, so we have the width of the hub to do. And if we look at our drawing, from the face to the back of the hub is 520 thousandths. Okay, and then our last dimension is from the face of the washer and the face of the front of the hub, which is going to shrink significantly to 8 thousandths, 0.008. Okay, so you get this little tiny feature there. Okay, at this point, we exit the dimension and our sketch should be fully constrained. We're going to accept that sketch. We're going to look at it at a 3D view, and we're going to go to Features, and we're going to do a Revolve Base. It's asking what side to go on, and it needs its axis of revolution, which is going to be the line here. And we hit Accept. So we now should have a wheel looking part with a hub that has a 8 thousandths protrusion on one side, and on the opposite side has a spud that sticks out. This part would be most likely a combination lathe and mill part, with the lathe work done first. And so I would suggest that this boss was made longer for work holding purposes. So you would first turn the first side, including this boss, and then the chuck could hold on to that with that spud for the second side and keep everything concentric. All right, we've now completed the revolve. Now the next feature we're going to make is a cutout, and then we're going to pattern that cutout to go around to make spokes. So we're going to go to Sketch, we're going to go to Sketch Mode, and we're going to select the plane that makes up the bottom of the recess, and then we will look at the model straight on in that view in the front plane. Now there are 3 of these features, so if we were to take 360 degrees and divide it by 3, you get 120. So we're going to start off with a center line that divides a series of center lines that is going to divide this wheel into a quadrant that is 1/3. Okay, so it wouldn't be a quadrant, would it? Be a thirdrant. Okay, so with those lines drawn, we're going to set the angle. Select our 2 center lines, and we should be able to get an angular dimension. So it's 120 degrees, and then we need to set it from vertical half of that to center it, 60 degrees. And we now have our center lines that we can use for construction. Alright, we're going to go back to look at our drawing, and our spoke is made up of a radius that's 710 thousandths radius, and another one that's 300 thousandths radius, and then lines offset such that the thickness of the spoke is 118 thousandths. So we're going to use half of that number to offset off the center lines we just drew. So let's start with our circles. So we're going to draw a circle, and it's going to start at origin, and we're going to snap about there. And we're going to draw a second circle, and we're going to snap about there. And then we're going to dimension the enter one. Okay, which the radius was, we're going to accept the dimension that's there. Then we're going to change the leader. So pick the leader tab, and we're going to switch to a radial leader, which will give us in radiuses what that diameter would be. And then that way we can match our drawing because this calls a radius. So the inner one was a radius of 300 thousandths. So we're going to change the value to 0.3, and it'll be the correct radius and diameter. We'll repeat that procedure on the outside one. So we're just going to go ahead and accept the existing dimension, but then go to leader lines and change it to radiuses, and then we would change the value of that radius to 710 thousandths. Okay, so now we have fully constrained circles that are the correct size. Now we're going to use the offset command. So we're going to hit offset entities, and we're going to offset our center lines to make up the width of the spoke. So on our drawing, it says that the distance between the spoke is 118 thousandths, so we need to divide that in half. So we can put in 0.118 divided by 2 is our offset increment, and then we're going to select our center line, and we're going to select below the line so it offsets in that direction. Now we should be able to come back and use the default settings to offset the second one. So we now have the lines and the arcs that we can trim up to make our feature. So let's do that now. We need to be a little careful how we do this, and you can achieve it by skipping this step and going to the fillet command, but I'm sometimes reluctant to do that. So I've picked the trim entities command. I'm going to use Smarter Super Trim. I'm going to trim off the legs of the lines that stick out past the arc. I'm going to do the same thing in the middle here to get those two trimmed off. And now the arc is going to be a little more tricky. We just have to trim off the tails to each subsequent intersection. So we're going to trim through here, here to that side of the arc, and that side of the arc. We're going to do the same thing there and there. And we should end up with a gray field that represents our cut. Now we've got this extra geometry out here which will cause problems. So what we want to do now is exit the trim command, and we're just going to highlight those features and delete them. So it's what's left of the circles we drew. We can keep the radius dimensions. We want those. Alright, so it should look something like this. Now we're going to put the fillets in the corners. We could put those in solid fillets, but because we're going to pattern this, I'm going to go ahead and do it as one feature, so we only have to select one feature to pattern. So we go to the sketch fillet, and our fillet size, according to the drawing, is a 100 thousandths radius. So we're already set at 100 thousandths, so now we can select our entities. So the arc, the line, the inside arc, the other line, and the outside arc. And now we have our 100 thousandths radiuses. Alright, we hit accept, and we have the cut that we want to make. So we're going to accept the sketch fillet. We're fully constrained. We're going to exit the sketch. Okay, zoom out to a 3D view. We're going to go to Features, Extruded Base, and select your sketch, which I had forgotten to select. Okay, and it defaults to blind, but we're going to do through all. So it goes all the way through the part and creates the window. Alright. So we have one of the 3 lightning holes that will make up the spokes of the flywheel.